Welcome. My name is Trisha Morris, and I would like to welcome you to my channel, Mathematics Simplex, where you will be able to view videos you might find difficult in your mathematics class. Please don't forget to like the video and subscribe to my channel. Today I'll be talking about differentiation rules. And the first rule that I'll be discussing is x to the n, where n represents my power. And to differentiate this, we'll have nx to the n minus 1. Now, say for example, we have x squared. When we're differentiating it, we first identify that our n is equal to 2. So applying this differentiation rule, we will differentiate x squared to have the 2 in front, right by the x. Then we say 2 take away 1. So it means that the answer for this is 2x. If I have x to the 5, then differentiating this, applying this rule, we put the 5 in front of the x, so it's going to be 5. Then we take away 1 from 5, so I'll have 5 take away 1. So my answer is 5x to the 4th. Suppose we have a negative power. So if I have x to the negative 4 and I am differentiating this, then again we will put the power in front of the variable. So we'll have minus 4x minus 4 take away 1. Now, if you realize for the power, we have two negative numbers. So we know if the signs are the same, we add and keep the sign. So in this case, we'll add negative 4 and a negative 1, so it gives us negative 5. Now, suppose we have 1 over x cubed. We can apply the laws of indices that says a to the minus n is 1 over a to the n. Now, if you don't remember this rule, you can always go back to my video where I was doing indices. So for this, we'll apply the indices rule that if I have a fraction, it is the same as x to the minus 3. Then we go ahead and differentiate. So I'll carry the negative 3 in front, right by the x, then minus 3 minus 1. So that means my answer is negative 3x to the negative 4. Say for example, we have 1 over the square root of x. Now what's going to happen is that we're going to apply indices rule that says square root is the same thing as a half. So this is x to the half. Then we can go ahead and rewrite this as x to the negative a half. Now we can go ahead and differentiate where we carry the negative a half in front. Then we subtract 1 from the power negative a half. So my answer is minus 1 over 2 x to the negative 3 over 2 or 1.5 if you want to have that. Now, if we have 1 over cube root of x, then it means I can rewrite it as x to the minus a third. Now, if you're not able to do this step right away, then you can do the following step where you rewrite the cube root as 1/3. So the cube root is the same thing as 1/3. Then you apply the rule that says this is the same as x to the negative a third. So differentiating this, I have minus a third in front. Then we subtract 1 from the power. So my answer here is minus a third x to the minus, in this case, this will be -1 and 1/3, and we can rewrite it as -4/3. So if we have 1 over, I'm gonna still use the cube root of x squared. That means I can rewrite this as 1 over, and this becomes 2/3. Again, this is coming from indices, so you can always go back to my video and go through the laws of indices. So rewriting this, I'll have x to the negative 2/3. Then differentiate, so I'll have -2/3 x minus 2/3, take away 1. So the answer is -2/3 x to the -5/3. And that's it. Very important to know that the derivative of a constant is 0. So if I differentiate the number 2, it's 0. If I differentiate the number 3, it's 0. If I differentiate e squared, that's a number, so that was 0. If I differentiate ln2, that's still 0 because ln2 is considered to be a number. Now remember, if I have e to the x, an exponential, it is the same thing as e to the x. And if I differentiate e to the 3x, the rule is that if I have e to the fx, then the derivative of this is f prime x e to the fx. So applying this rule, all it is saying is that we differentiate the power and put it in front of the exponential. So my fx in this case is 3x. So differentiating 3x, we arrive at 3. Then we rewrite everything as is. So this will be e to the 3x. So if I have e to the 2x squared, then I will go ahead and differentiate the power because this represents fx. So you differentiate the fx, 2 times 2, that's 4. Then you subtract 1 from the power. So that's 4x e to the 2x squared. The derivative of sine x is cos x. And we know cos x is minus sine x. So if I have sine 3x plus 1, then when I differentiate this, I will have 3 cos 3x plus 1. It's coming from this rule where if I have sine ax plus b, where a and b are constant, then the derivative of this is a cos ax plus b. So it means if I have cos ax plus b, then it means the derivative of this is minus a sine ax plus b. So if I have cos 3x plus 2, if I differentiate this, then I'll have minus 3 sine 3x plus 2. Now, the derivative of tan x is sec square x. So if I have it in tan ax plus b, then when I differentiate this, I will arrive at a sec square open brackets ax plus b. So if we have tan 2x plus 1, then it means it will give me 2, it will give me 2 sec square 2x plus 1. We also know that ln x is 1 over x. If I have ln fx, then the derivative of this is f prime over fx. For example, if I have ln 3x plus 4, and remember I have the modulus because we cannot find the natural log of a negative number. So we always have a modulus symbol. So differentiating the 3x plus 4, that's what we're seeing. So we'll arrive at 3, because when you differentiate 4, you'll arrive at 0. And the denominator will have the function, which is 3x plus 4. So if I have ln 2x squared plus x, then when I differentiate the 2x squared plus x, I will have 4x plus 1 over 2x squared plus x. And that's it for the natural log. Now, suppose we have a combination of functions. Say, for example, we have fx equal 3x squared plus 1 over x plus ln x plus 2. So the first thing we're going to do is write the symbol for the differentiation f prime. So this means I'm going to start to differentiate. And applying the rules that we just learned, we're going to differentiate this. So we say 3 times 2, I get 6. Then we subtract 1 from the power. So 2 take away 1. I'm left with 1. Now, 1 over x, the differential is not ln x. We can rewrite this as x to the negative 1. So differentiating this, we will arrive at, carry down the negative 1, so I have minus 1 x minus 1 minus 1. So you're taking away 1 from this, so you have a negative 2. The derivative of ln x is 1 over x, and when we differentiate a constant, that's 0. So now to simplify what we have here, we'll have 6x positive times negative, that's negative. And we know from indices, I can rewrite this as 1 over x squared plus 1 over x. Say we have fx equal 4x squared minus 3x cubed minus cos 2x plus 1 minus 5. It's a lot of minus. So to find the derivative, which is denoted by f prime, and please note, derivative can be f prime, it can be y prime, and it can be dy over dx. These are the three symbols that you can see. So differentiating 4x squared, we say 2 times 4, that gives me 8. Then we subtract 1 from this power, so we have just the power 1. Then 3 times negative 3, that's 9. Then we subtract 1 from this, I'm left with 2. So when we differentiate this cos, it's going to be a negative, but I'm going to show the steps. To differentiate the 2x plus 1, we arrive at 2. But because we're differentiating cos, it will be minus 2 sine 2x plus 1. And the derivative of the constant is 0. So simplifying this, we have 8x minus 9x squared, negative times negative, positive 2 sine 2x plus 1. If we have y equal 1 over x to the fourth minus 1 over the fifth root of x plus tan 2x. First, I'm going to do some simplification. So we know 1 over x to the fourth is x to the minus 4. If I have the fifth root from indices, it is the same thing as a power 1 over 5. 1 over the fifth root of x is the same as 1 over x to the 1 over 5. And we can rewrite it as x to the negative 1 over 5. So rewriting this, we have x to the minus 1 over 5. And then I have tan 2x. Now when we differentiate this, carry the negative 4 in front, then we subtract 1, so minus 1 from this, that becomes negative 5. Carry the negative 1/5 in front, it changes sign, so it becomes positive 1 over 5. Then we subtract 1 from this, so I have x to the 6 over 5. And then differentiating this, we have 2 sec square 2x. And that's it.